Hello there to all the beautiful DevOps engineers and developers listening to us right now. Amor, VP Product here at Groundcover. I have with me Ches, our CTO and co-founder. Say hi, Ches.
Hey guys, how's it going?
Great to be here with you today. We're going to talk about all things AI and our journey towards MCP creation and what does it mean? How does it enable you? And what is the future of AI development? You know, the little stuff's out there. So before we get started with the fun questions, to all of the people out there who are unlucky enough not to know what ground cover is, could you give us just a quick introduction on what we're doing and why we're doing it?
Sure. So GroundCover is a modern observability platform. We based on two different technologies that make all these things even possible. So the first one is eBPF sensor. To who doesn't really familiar with eBPF, eBPF is our way to get all the signals from the kernel without the developers even need to do instrumentation. So that really helps with third-party integrations or legacy code, or even just modern code that you didn't get to actually instrumented, which is apparently most of our code. So that's one thing. It helps us onboard new customers in minutes and not weeks and months of grinding of instrumenting all the application. And the second thing is our backend, which is based on our bring your own cloud model. What it actually means in simple word is that you create a new account for ground cover, and we deploy the backend inside your account. So all the data stay inside your account. Everything is inside your cloud, so very private, very secure. And the best part is that it's very cost efficient. So we can get you a lot more data in a lot more economical in terms of amount of data that you store.
So you basically don't need to have the trade-offs that you have in traditional observability. You don't need to choose what it is you monitor versus your bill at the end of the month. And I think that's going to be really important as well as we talk about kind of our value proposition when it comes to AI and ultimately the data you have. So I
Exactly.
thought to have this session in a way where we'll talk a little bit about kind of the macro and what gets us excited about AI a little bit, what gets us excited about the use cases, a little bit of the evolution, and then we could talk about how do we view it within ground cover, which I know is a conversation we have almost on the daily over here. So when we first look at it, I'd love to ask you like what in the world of use cases excites you when it comes to AI? How do you imagine kind of the near-term future changing as a result to this innovation?
Yeah, I know. It's a very interesting question because when I talk to peers, everyone is talking about root cause analysis, right? This is the holy grail that everyone is talking about in terms of observability. But when you go deeper and you ask yourself, okay, root cause analysis, obviously this is the dream, right? You don't need to wake up at night with finding what's happening. Some agent will tell you this is happening, this is the root cause, this is how you fix it, right? That's the dream. But when we got started and thought, how are we going to solve it? We actually understood that the main problem that prevent us to do root cause analysis at scale is actually making sense of the data before you have an incident. So we're talking about unstructured logs, right? Everyone has unstructured logs that someone wrote a few years ago, or they have like the Nginx that is unstructured logs, or you didn't have the right pipeline to parse it. Um, and we have those metrics that we often have, and it created high cardinality metrics, and we actually need to do stream aggregation or trace that are spam and etc. So what excites me actually is from being on the other side is I think it's very reasonable in a very short term that we can have some kind of agentic flow that could help us make sense of our data before we have an incident, and that will improve the developer experience every day, even regardless to incident. I'm sure we're gonna talk a little bit about how we can help in development cycle, but I think that's pretty excites me because imagine a world where you can go to your logs, whatever platform you use, and everything is structured, everything is pretty. This is something that we always strive to go there, but
Sounds like
never actually
utopia.
reach it.
Sounds
Yeah,
like utopia.
exactly. I think it's very feasible in the short term, and we're working very hard, as you know, at Groundcover to make it happen.
Yeah. So let's come back to that a little bit, how we think the short term is going to be changed. But one of the concepts that we often speak about over here is really about how do we go and create a knowledge density that is very, very high. And could you explain a little bit about what that means? You touched about it with, this plethora of logs and metrics you have and cardinality out the wazoo and, 1,001 different data points, or I should say 1,000,000,001 different data points that we see for each of our customers. And because we keep all of that data on their side, we don't need any of those trade-offs because the eBPF agent ends up getting deeper data. We often have challenges around how do we take all of that data and reduce it. Can you talk a little bit about what it is we actually did to figure out how to take a lot of data, compress it to a small amount so that ultimately AI could work much better with it?
Yeah, sure. I think we can start off with an example, right? So imagine we have a anonymous customer that sends 100K logs per second, and and that's not even a big customer. It's kind of medium customer. Um, the best agent in the world can have a context, limited context. Let's say 200K. Let's go for a megabyte or even 10 megabyte in the future. Um, that's not even close to what you need to send in order to make sense of those logs, right? So if you look deeper and understand, okay, those logs are probably somewhat repeatable, right? Because we have some execution flows, and they have um, logs with parameters inside, and it's being generated over and over again with different parameters inside. So what we did in order to tackle this specific approach, we said, okay, so eventually it collapsed to 10, 20, 30 patterns, maybe even 100 patterns. It's a no-brainer for sending it to LLM and make sense of it. So we just need to create some kind of pipeline that will transform those logs to patterns and learn the statistics around it. So imagine that we can tell the agent, look, those are the patterns in the system. And that's the trend of velocity of it. That's pretty compressible way to tell the agent to describe what's going on. And we can go even further, right? So we can tell it something about the parameters we see inside, and maybe it changes over time. So now we can tell, okay, this is an Nginx pattern. We usually have 99% of those parameters, 200 or 200, let's say it's a status code. And it shifted. So now we can see that there is 20% 500s. And this is 90% of solving the problem. We managed to compress the amount of the volume of data to probably the same knowledge, but in a much condensed way, which is how agents love to work, right? Because we have limited context, and we also don't want to spend so much money on it.
Absolutely. I think it's also how people love to work, right? I mean, the line is the same. How do we take a massive amount of data, be able to zoom into it, find something interesting, and then work out from that? In that terms, it's the same flow, whether it's a person, a DevOps engineer, a developer, or an agent on the other side. And you spoke about logs here as an example. Obviously, modern development logs are, almost something that we need to live with, but we try to move away from as much as possible. Could you talk to me a little bit about what are primitives that we work around actual spans and traces and communication around that, and what are we planning in that space?
Yeah, for sure. So we everyone wants to move away from logs, right? As you said, but it's really hard because it means to you need to instrument your application. And there is always some areas that you didn't cover or you manage to do that in the future. And the concept of distributed tracing is kind of broken if you have missing links. Um, but again, if you're using eBPF, you can get 100% visibility of that, and then the volume gets a lot bigger. And why is that? Because, for instance, in logs, if you had a lot of logs, you traditionally already thought about how you can minimize it because it was very pricey. So you sent it to some kind of a vendor, and the vendor kind of punished you with a extremely high bill, and you managed to reduce it, right? Unless you use ground cover, but
No, nothing like
most,
punishing you to make you act in check, right?
yeah, exactly. So in traces, we basically need to go the extra mile because the user didn't even do anything. It basically, created a ready server that's very high performance, and then you already all of a sudden you're seeing a million APIs per second, and you have this fork. Are you gonna save everything, or you're gonna do some kind of sampling? And if you do sampling, how can you still maintain 100% of the knowledge that you get from seeing everything because you run eBPF in the kernel? And the way we look at it at ground cover is, at the end of the day, we can describe traces knowledge into, who is talking to who, what are they talking about, which means, the resource. It could be the HTTP endpoint. It could be a Redis command. It could be a SQL that is being repetitive. And on top of those, fingerprint or some kind of a series that you create in terms of knowledge, we can learn statistics. So the obvious one is throughput, right? If A talking to B in the same HTTP endpoint, we want to know how many requests per second. We want to know the error rate, maybe latency statistics, P99, P95, P50, all the good measurement that we as an engineers really like. And the next question is that now that we managed to compress all that knowledge, is how can we use that as far as we can, it means in the sensor itself, to capture more knowledge. And what we did at ground cover is we used those statistics inside the process of sampling decision, and we made decisions on top of that. So we can see a span and see what quantile it is, and imagine it's a new P100. So it's the longest span that we ever seen between those two endpoints. And obviously, it's pretty interesting, right? It's more interesting than seeing another P50 or P95. So we can take all that knowledge, error codes and statistics, and put it inside the sampling mechanism at the root of where we generate the data, and then we can maximize of knowledge gaining relatively to the volume of data that's being collected. So this is another example where we can start the qualification process, if you want, or filtering process of what is important right where we generate the data. So we do the same. We take that concept very far, and we do that for every signal we collect, and everything is coming along with the same knowledge of how can we minimize the volume of data and maintain the knowledge that we can pass to our users, or do the same with the AI agents.
Amazing. So let's talk a little bit about AI agents. So let's talk a little bit about like MCP and the buzz in the world today, and how and what does it mean. So let's kind of double click here on what is MCP. Can you try to give me like a explanation as if I was five?
Yeah. So okay. So imagine that you have a smart agent, right? General purpose agent, and you want it to interact with a lot of different data sources, right? So you want it to interact with your repository, maybe it's GitHub. You want to interact with agentic flow that can do reasoning, general purpose reasoning, and you want to be able to help it with different data sources that it might need or might not need. So MCP is a way that can add tools, which is, you can think about it as data sources or endpoints or utility helpers that the agent kind of discover and it can learn how to use and use some kind of do SEOs to those MCP tools. You can tell it, you should use that when something happened. You can use that when you see these keywords. Basically make the agent smarter. And I would go even more. It's not just smarter, it's more contextual aware. So
We're extending agents essentially, right?
extending agents, definitely. Yeah.
And why is observability in your mind such an important data source to extend agents to? Like, what are the use cases that get you really excited in your day to day?
So what people mostly do with agents today, I think you'll find it funny, but we write more code with agents, right? That's one of the most common use cases for agentic flows. We can see Cursor and Windsurf and, all those guys in OpenAI just for this codex. And obviously the world is very bullish about helping write more code, making it smarter. Obviously the part of writing code is also debugging code, troubleshooting, understand what's going on in your production or in your dev environment. And I think one of the most meaningful data source is what actually going on. So you have your IDE, right, where you plan the code, but every engineer knows that what you plan and what you actually see in production is very different. So imagine a world where your agent can push code, new code, test it in real life, even in dev environment, release it to some kind of staging environment, and then run ground cover, which requires no additional instrumentation. We see everything, logs, traces, and metrics, and we can get it back to the agent in real time. So imagine you deploy a new version, and now you get logs from that version, you get traces from that version. It basically allows agents to close the loop by themselves. And that's very, very exciting because everyone that played with those IDEs that can help you write tools, you realize in a few minutes that tests are a crucial point of doing that efficiently. So you see the agent write some code, and then you ask for it to write tests to verify it, as you would expect from any engineer in your team. And then you see the tests fail, and they use logs, but it doesn't really simulate production, and it doesn't really cover everything. So imagine now you write code that require interaction with different services, and you get maybe 400 because the agent didn't understand exactly what endpoint to use. So I think observability data is actually the most important signal for AI agents that gonna write code. So that's very exciting. I think we haven't seen that yet.
Huge, huge. What do you think it means for the future of developers? Like, I've heard a lot of kind of dystopian talk of this is the end of the junior developer out there, right? And the skill sets that you're going to need in a few years from now is going to be very, very different. Do you have a strong opinion about that as someone who runs a top-notch R&D department?
Yeah, I'm thinking about it every day. I think it's going to change the way we write code. It's the focus shift to architecture, it shifts to writing tests and interfaces, things that agents still don't understand the full picture. And I think they will. But currently, when I use some kind of agentic code creators, I focus around the tests. I focus around the CI. I focus around how we make the test run very fast. How can we make sure what those agents wrote can actually run in production safely and do whatever we ask for it to do. So I'm not sure that we don't allow juniors to participate anymore. I just think it will shift the focus for them to be around testing, architecture decision, interface decision, because the code itself getting a little bit ephemeral. Like I don't get attached to that code anymore because I can replace it in a few hours. So what is important, and I think we're going actually backwards, because if you look at classic books of software engineering, Uncle Bob or are those gurus. They've been talking about tests, TDDs, all that like from the beginning as the most important interface. So I think it's going to shift heavily towards testing and interfaces, and the code itself going to get ephemeral. And the question that remains is who's going to troubleshoot and debug the code? And again, it means we're going to require those agents logging, and we're going to require them to do it efficiently, and we're going to require tracing and meaningful metrics in order for us to make sure that they're doing what we think they should do.
Absolutely. And what does it mean for the modern CTO, besides now being able to get back to writing code a little bit more?
Yeah, it's an amazing era. I can tell about myself that I've been writing much more than I would have before. In the last few months, I've been writing a lot of code. I can prototype things that before I had to ask for people to do for me because I didn't have any time for that. So I think everyone is going to get hands-on, which is a good thing because we also see it in product, right? You can use V0 and now Figma with the new release, everything is possible. I think we're gonna get more and more founder mode where engineers can do more product, backend can do more front end can do more backend. So DevOps is very in reach for backend developers and front developers than it was before. So I think it's very exciting because there are no barriers anymore. I don't know TypeScript, fine. I don't need to know. I know how to write tests. I know I want to see the interface. Cursor will help me do that. So I think we're going to shift from being very good at specific runtimes or languages and to understand software, understand interactions, understand system design. It's really, really exciting. And I think probably every CTO in the world is right now using those tools, understand what can they do better, even internally, even how can we improve our development cycle, where do we need to adopt tools to automatic code reviews, automatic testing. Very, very exciting.
Absolutely. We've heard from a lot of our customers these hackathons around Gen AI usage and just kind of really leaning into it. Obviously, we're at the beginning of this cycle still, but it seems like there's a lot of appetite from everyone to just figure out how to optimize and be more efficient and get the most out of their teams. So really exciting to look forward. So let's talk about our MCP. Obviously, we released our MCP just a minute ago, one of the first to the market as a observability provider to be able to allow AI agents to access this data. Huge believers in this, really bullish. Let's talk a little bit about ground cover MCP. What do you think is different?
I think we are doing extra effort to make it gain a lot of knowledge in a very short amount of time. So when we thought about MCP, everyone has the same dilemma. We can basically say, all right, we have APIs, right? We have SDK. Now you can just use it. You can access each and every API that we have. The truth is that you need a little bit of help in order to gain knowledge. So we can let the agent scan all the logs in the last hour with free text search. It's just going to take a lot of time. And also, I think it's going to get poor results because you can imagine how many logs the customer had. So instead, we're encouraging and we're generating new APIs in order to reduce the volume of data that returns from our MCP tools and still gaining a lot of knowledge. So heavily focus on patterns, heavily focus on changes, on infra changes, on issues, on monitors. So a lot of knowledge that agent can ingest in a very small, considerably amount of data.
Very true. ultimately it's these primitives that we know that people want to work with, agents want to work with. Looking at a billion logs, a billion traces, metrics to infinity is something that no person could do. So how could we expect agentic workflow to deal with it as well? Talk to
Yeah, I
me a
think
little.
just to add on that, I think the way we create it is we are thinking the same we're doing when we think about a product, right? When we think about the logs page on our platform, we know customer cannot just drill down 5 million logs. We need to somehow help the customer understand a spike in their errors or pattern that is being generated heavily in the last few minutes. So we took all that knowledge. So sometimes you can think about it, right? So when we have these insights on how to um, drill down on an issue, we kind of fork and think, okay, this is how the UI will look like, right? This is how the platform will look like, the user experience, what clicks can we do? And there is a parallel thinking about how the agent's gonna consume it. So, and essentially it's the same chain of thought. So we create a drawer where the user should click on it. And the same way we were trying to help the agent do the next tool. So now you fetch the patterns. Now you found an interesting pattern. Now get the examples. So it's the same way of thinking, just different outcome.
How do you think MCP changed our approach to moving towards root cause analysis and providing all of this tooling, and how much we've decided to invest into it?
I think when we started getting into MCP, everyone was thinking, okay, maybe we don't need to write our own agent, right? Because now we can connect Claude to our data sources in a smart way, and Cursor can integrate ground cover data from the repository, and that's going to be the best result we can get from root cause analysis. And when we play with it, we understood that there is a lot of domain knowledge that we can't condense into just MCP tools. So we kind of use it as a playground while we're developing our agent. So we trying new tools, understand how agents interact with it, understand how we want it to interact with it, and basically starting at the base ground where how we at ground cover look at agentic flow or root cause analysis, and we discover a lot of cool things. So actually, complex things like noisy neighbors are actually kind of easy for an agent to use MCP, right? Just give it a monitor, say it's an SLA breach. Now it can fetch traces, understand there is some traces that are good, some traces that are bad. Now it can just use our drill down, which is give us statistics of what represent the group of high latency and low latency, and it figure it out, right? It will say it's same nodes, and then it's gonna ask some questions about the nodes and understand it. But some simple things like understand where log an error log is actually meaningless because it has some baseline, and basically it's kind of drift away to it's kind of go into this rabbit hole of trying to understand some log where some random user, some random developer would just look at it and say, yeah, this is non-issue. This is stuff that's very really hard for a stateless agent that doesn't understand the system to get in a very short context. So we are working on creating this knowledge on your platform. So each and every company has this kind of knowledge on their systems, what is usually happening, what is very rare incident, how did we solve the last incident, some things that we are trying to collect and create some kind of organizational knowledge base on our system. So to give a short answer, we basically learn from it. We learn from the experience of MCP with interacting with other agents and improve our own agents to be better.
Very cool. One thing that kind of keeps me on my thinking is obviously we see this kind of like exponential growth in the ability to reason, in our ability to get value out of AI and all of the kind of potential use cases that it unlocks. How far away do you think we are from that kind of holy grail that you spoke about with, an agent going in, identifying the underlying problem, writing code, deploying, seeing that feedback loop, and iterating on top of it? And that sounds to me like not a 10x on engineer productivity, but a 100x on engineer productivity. Do you think we're months away from there, years away from there? When do you think this is a reality, especially with everyone's appetite for investment in the space?
Well, it's gonna be foolish for me to try to anticipate that because everything is changing so fast and everything's shifting so fast. So I don't know, but I think we're moving very, very fast, and things that were considered impossible weeks ago are very feasible today. I think that the bigger this is gonna happen, right? This is already started. I think the question that I focus around is how can we make it be safer? How can we make it be more predictable in order to make the adoption faster? I think if you don't have feedback loops, if you don't have guardrails that will tell you this code is misbehaving, not in a malicious way. I'm talking about bugs in production. I just saw this tweet of someone wrote that it used Devin AI and it costed $700 for 5 minutes in production because it added an event to post hook that was triggering a lot. It was in the hot path of the application. Who's going to look after this? This is a side effect of AI writing code, which was perfectly fine, I guess. So I think there are a lot of smart people in the world trying to make the code better, code that being generated by AI. I think we should focus around make it more observable, helping systems be self-healing using observability platforms in order to understand what's really happening inside production. We are basically the last mile. Like we are the platform that can actually tell you this is what actually happening inside your production. I think this will be probably the last barrier to unleash AI agent to write production code. Like I estimate that we're gonna have the capabilities of writing code sooner than we're gonna have capabilities of observing code and understand its behavior in production. So I think this will be the last enabler that we need to build in order to actually release it safely.
Absolutely. Absolutely. Now, let me take a little bit of a turn here. We spoke about, MCP AI, a little bit about ground cover. What else are you most excited about at ground cover in terms of what we're building right now? If you put aside kind of all of the investment we're doing on the AI front and on exposing that data systematically to agents,
So you mean
all of
everything
it,
we're
the,
doing?
the whole shebang. Give me one. Pick your favorite child.
Yeah, I think combining the in-cloud approach as an enabler. So, as we said before, right? Currently, we are stopping ourselves from getting more data because we don't have smart sensors, because it's too expensive, because we used to think about the observability platform as a SaaS platform. And go to a data oriented company and tell them you need to ship all of your data to some remote SaaS that you can't have access to that data. They will look at you very, very odd. So, and I think observability is often considered like a simple SaaS, but it's actually a data platform. And what's happening is that we're sending very little data that we can actually store and make sense of it. So for me, the in-cloud is the real paradigm shift. So as the bring your own cloud approach become more practical and we make it better and better, we currently support AWS, GCP, and Azure. And now it's feasible to send all of your data into one platform. And not only that, is we can actually generate automatically that data. So for me, it means 10x more data in probably half the price. So this will be the building block, right? So imagine those agents that we talked about, which is very smart and very cool. They're limited to the amount of data they can scan and ingest. So we're talking about 10x more data, half the price, and in a private and secure place where you can run your agents on top of that. To me, this is a completely paradigm shift on how we look at observability as a platform, and that's very exciting for me.
Yeah, so it's one of those things where I'm really proud to be at a company that we're able to kind of flip the script on how you approach observability. And you're able to think only in terms of what's best for the customer, because we don't need to live with any of those trade-offs around how much data are they going to push to us? How do we make sure that they don't push too much or penalize them or charge them more and then get to limits and all of these things? It's just anything that's important to you, you could have, and we'll help you get value to it. So it's a really big one. I think for me, one of the big pieces as well is all things around migration. Obviously, we have a ton of customers in their day to day using ground cover that have already moved over, but there's the whole world that hasn't yet. And try to think about how we could help them move over from these legacy providers, figure out how to reduce 90% of that effort, figure out how AI works into all of that solution, all of the efforts we've done around that. I think there's a lot of upside, a lot of value to be had to so many different companies by helping them figure that out.
Yes, for sure. I completely agree. The migrations part it's another example of things that a few months ago seems impossible, but currently with using LLM as the code generators, we can write a lot of code that will actually help customers migrate their legacy vendors into more modern stack. So that's definitely exciting and something that I personally take part in writing that code into the platform.
Absolutely. Now that our CTO has more time on his hands with the rise of AI IDEs and MCPs. Ches, thank you so much for the time. It was a pleasure speaking to you. All of our viewers and listeners out there, thank you for your time. Uh, Love that you're listening to us over here, and feel free to follow up with any questions you may have.